Hello class, welcome to Unit 8 Video 2. Today we're going to look at inverse functions and relations. So your learning target is that you can find the inverse of a function or a relation. The first thing we're going to do is look at relations. So in Unit 2 we talked about relations being a set of ordered pairs. So we're given the relation 1, 2, 3, 4, 5, 6. Those are ordered pairs. We need to identify the domain and the range. So the biggest thing to remember is the domain is your x values and your range is your y values. Okay, so the inverse, let's find the domain. So the domain is my x. Remember, we always list them in order. So we have 1, 3, and 5. Those are my x values and they're in numeric order. And then I'm going to look at my y values. I have 2, 4, and 6. So that's my domain, that's my range. Then an inverse relation is the set of ordered pairs that is found by reversing the x and y. Okay, so my domain and my range will switch. So if we have this relation, we want to identify the inverse relation. So just switch these around. So my new relation is 2, 1. Then I would have 3, 4. Or sorry, whoops, I forgot to flip that one, didn't I? 4, 3. And 6, 5. So an inverse is essentially just switching your domain and your range, your x and your y values, swapping them around. Okay, so we have the ordered pairs of the relation 2, 1, 5, 1, and 2, negative 4. They're also the vertices of a right triangle. It says find the inverse of the relation and then graph the two relations. Okay, well, the inverse relation would be just switching all my ordered pairs around. So instead of 2, 1, I now have 1, 2. Instead of 5, 1, I now have 1, 5. Instead of 2, negative 4, I now have negative 4, 2. So this is my inverse relation. So let's go ahead and graph them. Let's first graph the original relation. So we have 2, 1, 5, 1, and 2, negative 4. So this is my original, relation. Okay, there's my triangle. It's not perfect, but it's going to have to do. Then my inverse relation, let's go ahead and graph that. We have 1, 2, 1, 5, and negative 4, 2. So you should see the triangles are exactly the same. If you drew yours a little bit nicer than I drew mine, you'll see that they're the same size, same shape. One thing I would like to point out is that if I draw in the line y equals x, if I draw in y equals x, right here, do you notice that if you flip them across this line, you get the same thing? So one thing to note is that for inverses, this is the equation y equals x, they are symmetric across that line. You know, if I take this and flip it, if I divide my paper in half diagonally this way, it would match up. So one thing to note about inverses. Okay, so that's relations. That's when you have ordered pairs. Now we're going to look at inverse functions. So this is when you have an equation. Okay, so the inverse function f of x is f inverse of x. So this negative 1, you don't say f to the negative 1. This is f inverse of x. And that says if f of a equals b, then f inverse of b equals a. So essentially what it's saying is if you plug in a, you get out b. If you plug b into your inverse, you get out a. So they swap places. Okay, just like we were switching ordered pairs before. This is essentially the ordered pair AB. This is the ordered pair BA. Okay, so it says find the inverse function of f of x equals x plus 2. Okay, the way you're going to do this is we are going to solve for x. That's step 1. Okay, so I'm going to rewrite it. Y equals x plus 2. Then I go ahead and I'm going to solve for x. So in order to get x by itself, I would subtract 2. Okay, solve for x. That's done. Step 2, and we're going to just put it into function notation. Or inverse notation. Inverse, which is a form of function notation. All right, so my inverse notation is f inverse of x is equal to, okay, now instead of writing y, we write x minus 2, okay, because I'm plugging in x. So this is my notation for my inverse. So now it says evaluate f of 5. This is f of 5, so that means I'm going to use this one. So f of 5 is equal to 5 plus 2, so that gives me out 7. So this is really the ordered pair 5, 7. Now it's telling me to use my inverse. So if I do the inverse of this ordered pair, essentially I should get out 7, 5. So let's check if I found the correct inverse. So it's the inverse, so I'm using this. 7 minus 2, does that equal 5? Yes, it checks out. Okay, so that is my an example of finding the inverse and then plugging in points to see if you did it correctly. Example 2 says find the inverse of f of x equals x plus 6 over 2. So first thing we do is just rewrite it as y equals x plus 6 over 2. We solve for x. First thing I'm going to do, multiply by 2. So I have 2y is equal to x plus 6, because those canceled. Now I would subtract 6. 2y minus 6 can't combine them. They are not like pairs. So we have 2y minus 6 equals x. Now I just put it into inverse notation. So I essentially rewrite, this is a y and this is an x now. So we have f inverse of x equals 2x minus 6. The notation's a little silly, but see how we have an x here? So it means when I write it, I rewrite it with an x. Okay, example 3. Find the inverse of 5x plus 10. I would like for you to pause the video and try this one on your own. Okay, hopefully you paused the video and tried it. So we rewrite y equals 5x plus 10, and now I solve for x. So I would subtract 10, and then I would divide by 5. So my inverse, so in inverse notation, f inverse of x is equal to x minus 10 over 5. Another way that you could write this and would be completely acceptable would be f inverse, whoops, you can write it a little bigger down here. F inverse of x is equal to, I could divide each one by 5. X over 5 minus 10 divided by 5 is 2. This one is equally acceptable as well. Okay. So that's example 2 and 3 on how to find an inverse. If you have any questions on how to find an inverse, please let me know. We are going to move on to an example that says to determine whether f of x and g of x are inverses. Okay. This will come up on your review guide for this unit, so make sure you're paying attention. But if you need to show that something is an inverse function, you need to do a composition. We need to do f of g of x, and you need to show that that equals x. And you need to do g of f of x, and you need to show that that is equal to x. Okay? You need to check both. Okay, so fair warning, you will have something like this on your review for this quiz. So make sure you're listening and paying attention. Okay, so starting out with, I need to find f of g of x. So this comes from last unit, so composition, or not last unit, but last lesson. Taking g and plugging it into here. So I have 3 over 4, plugging in all of g, 4 thirds x plus 8 minus 6. Distribute. 3 over 4 times 4 over 3 is 1, so I just have x, plus 3 over 4 times 8 over 1 minus 6. Okay, let's just simplify. 8 divided by 4 is 2, so I have x plus 3 times 2 is 6 minus 6, which gives me, those cancel, x. So there's my first thing. I did this. Now I need to go ahead and do it again. This time I need to do g of f of x. We need to check that one. So we're going the opposite way. We're taking our f of x function, plugging it into g. So we're taking all this, plugging it into here. So we have 4 thirds, 3 over 5x minus 6. plus 8. That, my fractions will cancel, so I'm left with x. And if you don't see that they cancel, you literally can go on your calculator and type in 4 divided by 3 times 3 divided by 4, and it will give you 1. Okay, the next thing I'm going to do is I'm going to do 4 divided by 3 times 6. Should give us 8. Okay, so that's one way. You can do it on your calculator. Otherwise, I'm going to show you how to do it algebraically. So if I distribute here, I have minus 4 over 3 times 6 plus 8. 6 divided by 3 is 2. So I have x minus 4 times 2 is 8 plus 8. So those will cancel. So I'm left with x. So that checks out right here. Okay, so I checked both. They both equal x. So guess what that means? They are inverses. So yes, they are inverse functions. Yay, smiley face. All right, so that is example 4. If you have any questions, let me know. I promise you this problem is coming back. So if you have questions, make sure you ask. All right, the next one. Example 5 says, find the inverse of a of r equals pi r squared. Okay, well, this one is talking about the area of a circle. Okay, whenever it is a real life situation, okay, or a real life equation that you use, leave the variables. Okay, before we were switching at the very end, we would put x in the spot of y. But for real life situations, do not switch the variables. It will get more confusing when you are using problems like this. So find the inverse. So a equals pi r squared. So I would solve for r. I meant to grab a different color, divide by pi. So I have a over pi equals r squared. Now, how do I get rid of r? Take the square root. Remember when I take the square root, 2 answers, plus or minus. Okay, so I have r is equal to plus or minus the square root of a over pi. Okay, do I ever want a negative radius? No. So my inverse for this one is r is equal to the square root of a over pi. So there is my inverse. Okay, so what does this inverse function tell you? It tells me when I plug in area, I'll get out my radius. That's why we don't want to switch the variables. It'll just make it more confusing. So our next one says, find the radius of a circle with an area of 314. Okay, so let's do that. Which one would you want to use? I know the area, and I want to get out radius, so I'm going to use the inverse. So my radius is equal to 314 over pi. Take the square root of it. So on your calculator, we go second square root 314 divided by second pi, which is right here above this, and hit enter. And I would round to 3 decimal places, so this 4 tells me to leave 7, so it's 9.997, and I would label it centimeters. So that is my radius for this problem. Okay. We have one last problem, example 6. It says the formula used to convert degrees Celsius to Fahrenheit is f of x equals 9 over 5x plus 32. Find f inverse of x. Okay, so I want to get x by itself. So I'm just going to rewrite. I have f is equal to 9 over 5x plus 32. First thing I would do is subtract 32 from both sides. So we have f minus 32 is equal to 9 over 5x. Multiply both sides by the reciprocal. Both sides, so I had to put this in parentheses. These will cancel. And so I'm left with x is equal to 5 over 9 f minus 32. Okay. This one is a real life situation, but do you see how this tells me to find f inverse of x? So it wants us to rewrite this one in that notation. Okay, so my final answer would be f inverse of x is equal to 5 over 9, and now I would write x minus 32. Okay, so there's my notation. Okay, so this equation, you plugged in Celsius and you got out Fahrenheit. It says, what can F inverse be used for? Now we're going to plug in Fahrenheit and get out Celsius. So what is it used for? It's used to convert from Fahrenheit to Celsius. Okay, so if I said I have 32 degrees Fahrenheit, what is that in Celsius? You'd plug it into here. If I said I had 32 Celsius, you'd plug it into this one to get out Fahrenheit. It all depends on what the question is asking. Okay. Otherwise, that is it for Unit 8, Video 2. If you have any questions, please come and ask. Otherwise, have a great day, and I will talk to you later.